All right, good morning and welcome to the first lesson of this year. So yesterday in class, we created our Delta Math account. If you weren't here going to It's Learning, you can follow the instructions from yesterday, 1-4-22, and create that account. It was a very simple assignment then we kind of talked about. Probably took us about 10 to 15 minutes in class. But go ahead and do that. But then today we are going to build on that and talk about degrees and radians. And the best example I can think of for these degrees and radians is much like when we use a ruler, we can measure in both inches and centimeters. They mean the same thing, it's just a different unit of label. And in the same way, today we are going to be talking about degrees and radians. They both tell us an angle measure. So like if we look here at this angle, here I'll zoom in on it, it tells us how big this gap is in between what angle is formed, whether it's in degrees or radians. They are just two different ways to label it, so two different units we can think of. Okay, now with our angle, a couple things we want to point out. The vertex, hopefully you know that's like your corner here, and as we have our angle here, we have two different names. Our initial side, that's where it begins, right? Initial is the starting point. Terminal is where it travels to. So if this angle is opened up, here starts at 0. If we think back to yesterday, up here where my cursor is, that would be 90. So this one, I don't know, about halfway in between there, probably about 45 degrees where the terminal side goes. But we're not concerned with that. Just the key thing is this would be a positive angle because it goes counterclockwise. So when is an angle positive, that's when it goes counterclockwise. We talked about this some yesterday. However, if it goes the other way, if it goes down, if it goes clockwise, that is negative. And this one looks about to be negative 45. Yeah, obviously I haven't measured it, but I think it's very close to that. And that's when we go clockwise. All right, now if we think about it, if we would go the full way around, we talked about this, the full way around the circle, that's going to be 360 degrees. So how many degrees are in one complete counterclockwise rotation? 360 degrees. And some of you might wonder, why is this word in there? But in order for it to be 360, it has to be counterclockwise. If it was clockwise, it would be negative 360 degrees. Okay, now the question is, how many radians are in one complete counterclockwise rotation? And before we can talk about that, we need to understand what a radian is. So right here it says a central angle is an angle that has its vertex at the center of a circle. So if we look here at this circle, here's our radius, here's our vertex right in the center. And if we have an intercepted arc's length that is equal to the radius, so what that means is, you see the radius here is r, the radius here is r, that's going to be the same. The radius is always the same because it's the distance from the center point to the edge. So that will always be consistent. And that radius, if we would lay that around the edge here, this is our intercepted arc. Do you see how this arc is r as well? That is the same length as the radius. If that is the case, we call that 1 radian. Now if we would trace around, here would be a radian, here would be a radian, here would be a radian, here, 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 and it goes around a little bit more than 6 radians. Now, if we want a more precise answer for this, we can go ahead and call that 2 pi radians. Okay, so 2 pi radians, which some of you might think 2 pi, that's not close to 6, but pi is 3.14, right? It keeps going, going, going. So 2 times 3.14, something around 6.28. So 2 pi radians is how many radians would be in one circle. So if we think about it, we've got like the first one right there, then 2, 3, 4, and obviously I'm estimating this, but 5, 6, and then this little chunk, the 0.28, okay? So 2 pi radians. Now, if we think about it, if one full rotation around the circle we said is 360 degrees, and we know that one full rotation in radians is 2 pi, since both of those represent one full rotation, we can set those equal to each other. So 360 equals 2 pi. If we divide by 2, then that tells us that 180 degrees is equal to pi radians. Okay, so 180 degrees will be equal to pi radians. Now, if that is the case now, that means if we are going to try to convert between these, okay, if we have degrees and we're trying to convert to radians, since 180 degrees is equal to pi radians, if we multiply by pi and then divide it by 180, we will get the degree to turn into radians. Okay, so we'll multiply by pi divided by 180. Now, on the next step, it says to convert from radians to degrees. We'll just do it the opposite way. Now, I did make a typo here. Instead of multiply the degree, it should say multiply the radian. So multiply the radian measure by 180, and then we'll divide that by pi. Okay, so if we look here on the back, so if our job is to convert from degrees to radians, okay, remember we said if it's from degrees to radians, all we have to do is multiply by pi, divide by 180. So, and the nice thing about this, if this is 180 degrees, that'll cancel with our degrees, and then we'll be left with just radians as our answer. So we do not have to write radians every time, but 45 times pi divided by 180. Remember, when you multiply, you go straight across. Technically, 45 is over 1, so 45 pi is what we'd get on top. 1 times 180 is 180. Now, at this point, we need to reduce. We need to think what goes into both 45 and 180. And if probably lots of you will think 5, which is fine if you do that, but we can actually get something bigger into both of those. 45 actually goes into 180 4 times. Okay, so we reduce 45 goes into 45 one time, so we're left with just 1 pi or pi on top. 45 goes into 180 4 times, so pi over 4 radians is our answer. Now, if you had done that by 5, you would have gotten 9 over 20 radians, so which is fine. Sorry, I misspoke. 9 over 36, because 5 goes into 45 9 times. 5 goes into 180 36 times. That would be fine, but then you would have to keep reducing, which 9 does go into 36 4 times, so it would still work out. Okay, our next one. We've got 135 times pi over 180. Once again, that'd be like over 1, so 135 pi over 180. 45 goes into 135 3 times. 45 still goes into 180 4 times. So 3 pi over 4. So if I were you, maybe pause and try C, D, E, and F. That'll be the best way you can get a little practice here. I'm going to keep going. So we do 90 times pi over 180. Right, we get 90 pi over 180. If we reduce, that becomes pi over 2. This 90 goes into 180 twice. Okay, our next one, 450. And once again, all we got to do is multiply by pi over 180. So this one starts to get a little bit bigger. 450 pi divided by 180. Now, if this gets a little more confusing, here's a hint. If they both end with 0, we know that cancels out. Now we're down to 45 and 18. That's maybe a little easier to manage. 5 pi over 2, because 9 goes into both of those. Next one, 120 times pi over 180. This will give us 120 pi over 180. It's the same process every time. Once again, the zeros cancel. 12 over 18. That reduces to 2 over 3, so 2 pi over 3. And our final one, 360. Now, some of you might already know what this is. We should. If you don't remember, that's okay. We'll get 360 pi over 180. The zeros will cancel. 18 does go into 36 twice, so we'll be left with just 2 pi. Hopefully that makes sense, because remember we said 2 pi was equal to 360, so they both represent one rotation around our circle. All right, now our next one here, radians to degrees. Okay, we want to multiply by 180 divided by pi if that's the case. We're going the opposite way, so we just flip those, 180 over pi. So from radians to degrees, we have 3 pi over 4 times 180 over pi. Pi's will get canceled. 3 times 180, so that'd be 300 for 3 times 100. 3 times 80 is 240. Add that, so 540 over 4. Once again, remember these pi's will cancel. 4 goes into 540 135 times, and this is in degrees, so put our label. We are done. If you're not sure I did that, I'll do it one more time. So, or I guess 5 more times. 5 pi over 3. We multiply by 180 over pi. And maybe I'll use color to make this more obvious. The pi's cancel. Okay, and now 5 times 180, 5 times 180 is going to be 900. Divided by 3 would give us 300 degrees. All right, next one, 3 pi. If we're going to degrees, 180 divided by pi. The pi's cancel. 3 times 180 is 540. We don't have to reduce because there's nothing on the bottom. So 540 degrees. All right, 3 more, and then I'm done for today. So our next one, 2 pi times 180 divided by pi again. And hopefully you know the pi's will cancel. 2 times 180 is 360, which makes sense. Once again, D is the same. It matches up here with letter F, okay? Much like here we had A that matched up with letter B up the top, okay? Our next one, 7 pi over 12. So 7 pi over 12 times, if we have 180 divided by pi. Okay, so these pi's will cancel. 7 times 180 is going to be 1260. 12 times 1 is still 12 on the bottom. Now we can reduce. 12 does go into 1260 105 times, so 105 degrees. I forgot to box this. Okay, final one, final problem of the day. 5 pi over 6, if we times that by 180 divided by pi, the pi's cancel. 5 times 180, it's going to be 900 divided by 6. 6 will go into 900 150 times, and we are done. So, hope you guys were able to catch on and figure this out. If not, go back, watch the video again if you need to. If you have questions, definitely reach out to me. I'm happy to help. There is a brief delta math assignment just doing these 2 different steps. So going from degrees to radians and radians to degrees. So if you have questions, reach out, let me know, but let's get that done, and hope you have a good day, and I'll see you tomorrow.